Hello there, and welcome to this quiet space where history slows down and questions are allowed to settle without needing immediate answers. Tonight, we're not exploring distant galaxies or abstract theories about consciousness. Instead, we're looking at something closer, something that brushes against the edges of what actually happened and what might have been. We're going to ask a simple question that opens onto complicated territory. What if Neanderthals had not gone extinct? Not as a fantasy or a thought experiment divorced from reality, but as a genuine alternate path grounded in what we know about their biology, their minds, and the world they inhabited. Before we begin, I'd like to know where you're listening from tonight and what time it is where you are. It's a small thing, but there's something comforting about it. Here we are, separated by distance and time zones, yet connected by this shared curiosity about the deep past and the roads not taken. If this kind of slow-burning question appeals to you, I'd be grateful if you considered liking or subscribing. It helps this quiet signal reach others who might appreciate it. No pressure, of course, just an invitation. So, settle in. Let your thoughts slow to the pace of glaciers moving across continents, to the rhythm of genes passing through generations, to the quiet accumulation of small differences that, over tens of thousands of years, determine which lineages persist and which fade into stone. We're going to spend time with a species that was not a failed experiment or a primitive ancestor. They were something else entirely, a sister lineage, a parallel humanity, and their disappearance was not inevitable. It was contingent, the result of pressures both environmental and competitive, playing out across millennia in ways that could, under slightly different circumstances, have resolved differently. Tonight, we'll build a careful picture of what they were, how they lived, and what their survival might have meant for the shape of human history. We'll move slowly through the evidence, through the implications, through the questions that don't have easy answers. There's no urgency here, just the steady unfolding of a story that almost was. To understand what a surviving Neanderthal population might mean for the modern world, we need to begin with the body itself, not as metaphor or abstraction, but as a biological fact, a specific set of adaptations that shaped everything about how these people moved through their environment. The Neanderthal form was robust. That word appears repeatedly in the scientific literature, and it's the most accurate descriptor available. They were stocky, barrel-chested, with limbs that were proportionally shorter than those of modern humans. This wasn't accident or variation. It was adaptation, the product of hundreds of thousands of years spent in the fluctuating cold of Ice Age Eurasia. The principle is straightforward. In cold climates, a compact body with reduced surface area relative to mass retains heat more efficiently. Shorter limbs mean less exposure, less area from which warmth can radiate away into frigid air. The Neanderthal build follows this pattern perfectly, a textbook example of what evolutionary biologists call Bergmann's and Allen's rules, the same principles that govern body shape in Arctic mammals. But the robusticity went deeper than limb proportions. Their ribcage was wide, flaring outward in what researchers describe as a bell shape. This wasn't simply aesthetic. It accommodated a large respiratory system, one that could support intense bursts of physical activity. The skeletal structure suggests a body built for power, for short, explosive efforts rather than endurance running. Their bones were thick, their muscle attachment sites pronounced. This was a frame designed to carry substantial mass and generate significant force. That force came at a cost. A larger body with greater muscle mass requires more energy to maintain. The basal metabolic rate, the amount of energy needed just to keep the organism functioning at rest, was higher in Neanderthals than in the more gracile Homo sapiens. They needed more calories, consistently, just to sustain normal bodily function. This wasn't a minor difference. It was a fundamental constraint that shaped their entire subsistence strategy. The fossil record, combined with isotopic analysis of their bones, reveals the consequences of this constraint. Neanderthals, particularly those living at higher latitudes, relied heavily on large game. Their diet was protein-rich, centered on hunting megafauna, the large herbivores that roamed the Pleistocene landscapes. In Mediterranean regions, the picture is slightly more varied, showing some incorporation of plant resources and smaller game. But in the colder northern ranges, the pattern is consistent. They were specialized carnivores. This specialization was effective in a resource-rich environment. The Ice Age, for all its harshness, supported abundant populations of large herbivores in certain ecosystems. Mammoths, bison, reindeer, these animals provided dense packets of calories and fat, exactly what the Neanderthal metabolism required. The archaeological evidence shows they were successful hunters, capable of bringing down dangerous prey using close-range weapons. But specialization is always a trade-off. A body and a culture adapted to exploit a specific resource becomes vulnerable when that resource fluctuates or disappears. The Neanderthal physique represented a biological commitment. It was an investment in a particular way of extracting energy from the environment, one that worked brilliantly under the right conditions but offered little flexibility when conditions changed. Their facial structure, too, was distinctive. Large nasal cavities dominated the midface, creating the characteristic Neanderthal profile. For a long time, this was interpreted purely as an adaptation to cold air, a way to warm and humidify breath before it reached the lungs. Recent analysis has complicated that picture. While the nasal passages did function effectively in cold climates, their size and shape were also influenced by overall body size and the structural demands of their robust skull. It wasn't a simple one-to-one adaptation, but rather part of a complex suite of features that defined the Neanderthal form. What's important to understand is that this body wasn't primitive. It wasn't an early draft that Homo sapiens later improved upon. It was a different solution to the problem of survival, optimized for different conditions. In the environments where Neanderthals evolved, their build provided real advantages. Strength, power, cold tolerance, the ability to process and utilize high-protein diets efficiently. If Neanderthals had survived into the modern era, this physique would have persisted as a defining characteristic. Absent some dramatic shift in selective pressures, there's no reason to think they would have evolved toward the lighter build of Homo sapiens. Their body would remain distinct, immediately recognizable, a permanent marker of their separate evolutionary history. In a contemporary context, that robusticity would translate directly into capability. Physical strength would not be distributed evenly across the two human species. Neanderthals would retain an advantage in tasks requiring raw power, in environments that challenge the limits of human endurance. This isn't speculation about ancient hunting prowess. It's a straightforward extrapolation from skeletal structure and muscle architecture. If the body survived, the capability would survive with it, and that capability would shape everything else. Economic roles, social identity, the way the two populations interacted and understood each other. Because in a world with two human species, difference isn't abstract, it's embodied. It's visible in posture and proportion, measurable in strength and caloric need. The Neanderthal form would be a constant, unavoidable fact, grounding all subsequent questions about coexistence in the reality of distinct biology. The structure of the Neanderthal skull reveals something unexpected when examined in detail. Their eye sockets were notably larger than those of early modern humans. This isn't a subtle variation. It's a measurable, consistent difference across the fossil record, significant enough to indicate a functional adaptation. The interpretation is straightforward. Larger orbital cavities accommodated larger eyes, and larger eyes served a specific purpose. They gathered more light, improving visual acuity in low-light conditions. This makes sense given the environments Neanderthals inhabited. The higher latitudes of Ice Age Eurasia experienced long winters, with abbreviated daylight hours. Light levels were consistently lower than those encountered by early Homo sapiens evolving in Africa. Vision is expensive, neurologically speaking. The human visual system, even in modern Homo sapiens, consumes a significant portion of the brain's processing power. Larger eyes require not just larger optical structures, but more neural tissue dedicated to processing the information those eyes collect. The visual cortex must expand to handle the increased input. The brain regions controlling eye movement, managing focus, integrating visual data with spatial awareness, all of these must scale accordingly. Neanderthal brains were similar in overall volume to those of early modern humans. In some cases, the endocranial measurements suggest they were slightly larger, but size alone doesn't determine cognitive capacity. What matters is how that volume is organized, which functions receive priority in the allocation of neural resources. The evidence indicates that a substantial portion of the Neanderthal brain was devoted to visual processing and to managing their robust bodies. The neural pathways controlling a heavily muscled, powerful frame require more extensive networks than those needed for a lighter build. More neurons dedicated to motor control, more tissue devoted to proprioception, the sense of where the body is in space. This creates a fundamental constraint. If a significant fraction of the brain is committed to vision and body maintenance, that tissue isn't available for other cognitive functions. The brain operates within limits. Total volume is finite. Expanding one system necessarily means constraining another. Comparative analysis of Neanderthal and modern human skull anatomy reveals the consequences. The regions of the Neanderthal brain associated with higher-order cognitive functions, specifically the parietal lobes and portions of the cerebellum, were proportionally smaller than those in Homo sapiens. These areas are linked to several critical capabilities: working memory, the ability to hold and manipulate information temporally; cognitive flexibility, the capacity to shift between tasks and adapt strategies; and perhaps most significantly, social cognition, the complex processing required to navigate large social networks. This doesn't mean Neanderthals were less intelligent in any absolute sense. Intelligence isn't a single variable that can be ranked on a linear scale. It's a collection of capacities, and different cognitive architectures prioritize different elements of that collection. What the evidence suggests is that Neanderthal cognition was organized differently. Their brains appear to have been optimized for certain tasks at the expense of others. They likely excelled at spatial reasoning, at maintaining detailed mental maps of their territory, at tracking prey across complex terrain. Their enhanced visual system would have supported precise depth perception and accurate assessment of distance, critical skills for close-range hunting. But the trade-off was real. The smaller parietal lobes and reduced cerebellar hemispheres suggest constraints in other areas. Social group size in primates correlates with the size of specific brain regions, particularly the neocortex. The relationship isn't absolute, but it's consistent enough to be predictive. Smaller regions associated with social processing indicate a reduced capacity to manage complex social relationships across large networks. For Neanderthals, this likely meant they functioned most effectively in smaller, tighter-knit groups. Their social structures would have been intimate, with each individual maintaining close relationships with a limited number of others. This isn't a deficit. Small groups can be highly functional, cohesive, and effective, but they operate under different constraints than large networks. Cultural transmission in small groups tends to be conservative. Information passes through direct teaching, through close observation and imitation. Innovation can occur, but its spread across the population is slower because there are fewer connections between groups, fewer opportunities for ideas to jump from one community to another. Archaeological evidence supports this picture. The Neanderthal tool tradition, the Mousterian industry, shows remarkable stability over long periods. The techniques are sophisticated, but they don't change rapidly. The same basic forms persist across tens of thousands of years. The developmental path of the Neanderthal brain also diverged early. Brain size at birth was comparable between the two species, but the pattern of growth during infancy differed. This early period is critical for establishing neural architecture. Different growth patterns during the first months and years of life lead to different adult brain structures. The organization is set in motion early, shaping the trajectories of cognitive development. If Neanderthals had survived, this fundamental difference in brain organization would persist. It's not something that could be easily modified through cultural practice or education. The architecture is biological, built into the developmental program, a product of deep evolutionary history. In a modern context, this would manifest as a distinct cognitive profile, not better or worse, but different. Neanderthal minds might approach problems with a different set of strengths and limitations. Tasks requiring visual precision, spatial navigation, and detailed environmental knowledge could come more naturally. Abstract reasoning divorced from concrete context, managing information across large social networks, rapid cognitive shifting between unrelated tasks. These might present greater challenges. This matters profoundly for the question of coexistence, because if two human species share the world but think differently, that difference will permeate every interaction. Language, education, legal systems, the design of cities and institutions, all of these are built around assumptions about how minds work. A world with two cognitive architectures would need to accommodate both, to find ways of structuring society that don't privilege one pattern of thought over the other. The Neanderthal brain, organized around vision and physicality, represents an alternate solution to the problem of intelligence, and if it had survived, it would stand as a permanent reminder that there is no single way to be human, no single path to complex thought. The mind, like the body, is contingent, shaped by environment and history into forms that work but might have worked otherwise. The picture emerging from neuroscience and paleoanthropology is one of constraint and compromise. The Neanderthal brain was not inferior. It was differently optimized, the product of evolutionary trade-offs that allocated cognitive resources according to the specific pressures their ancestors faced. To understand this, it helps to consider how brains evolve. Neural tissue is metabolically expensive. The human brain, despite representing only about 2% of body weight, consumes roughly 20% of the body's energy at rest. This creates pressure. Any expansion of brain size or cognitive capacity must justify itself in terms of survival and reproduction. Evolution doesn't build brains for abstraction's sake. It builds them to solve problems. For Neanderthals, the problems were specific. Survival in Ice Age Eurasia required hunting large, dangerous animals at close range. It required navigating through varied terrain, often in low light, across seasons that shifted between tundra and sparse woodland. It required tracking prey over long distances, reading subtle signs in the environment, maintaining a detailed mental catalogue of resources and risks within a territory. These demands shaped their cognitive priorities. Enhanced vision served them well. Larger eyes and expanded visual cortices made them effective in dim conditions, gave them better depth perception, allowed more accurate assessment of movement and distance. This was directly useful. It translated into better hunting success, fewer injuries from misjudged strikes or falls, more effective navigation through complex landscapes. Similarly, their robust bodies, while energetically costly, provided advantages in their niche. Strength allowed them to bring down large prey. Cold adaptation let them exploit northern ranges that might have been marginal for more gracile populations, but managing that body required neural investment. Motor control for a heavily muscled frame is complex. It demands more processing power than controlling a lighter build. The consequence of these adaptations was that other cognitive capacities received relatively less emphasis. The brain's total volume couldn't expand indefinitely. There are limits imposed by maternal birth canals, by the energy available to support neural tissue, by the time required for development. Within those limits, trade-offs are necessary. The regions most reduced in Neanderthals, relative to Homo sapiens, were the parietal lobes and the cerebellar hemispheres. These areas serve multiple functions, but one of their key roles involves integration. The parietal lobes help integrate sensory information from different sources, support working memory, and contribute to the flexible manipulation of mental representations. The cerebellum, once thought to be purely involved in motor coordination, is now understood to play a significant role in cognitive processes, including language, social cognition, and the sequencing of complex behaviors. Reduced volume in these areas suggests constraints in the cognitive capacities they support. This doesn't mean Neanderthals lacked these capacities entirely. It means they likely operated with less bandwidth, less ability to juggle multiple streams of information simultaneously, less flexibility in rapidly shifting cognitive strategies. One area where this constraint would manifest is social group size. There's a well-established relationship in primates between neocortex size and the number of stable social relationships an individual can maintain. This relationship, often called Dunbar's number, after the researcher who first described it, suggests that humans can maintain roughly 150 meaningful social connections. The number isn't fixed, it varies across populations and contexts. but the principle holds. Cognitive capacity limits social complexity. For Neanderthals, with proportionally smaller regions associated with social processing, the effective group size was likely lower. Perhaps they could comfortably maintain relationships with 50 individuals, or 75, not hundreds. This would shape their social organization fundamentally. Small bands, tight kinship networks, less interaction between distant groups. Small groups have advantages. Trust is easier to establish and maintain. Communication is more direct. Cooperation can be enforced through personal reputation and immediate reciprocity. But small groups also face limitations. They're vulnerable to demographic shocks. A bad winter, a hunting accident that kills several adults, these events can devastate a small population in ways that a larger network can absorb. Small groups also limit the rate of cultural innovation. Ideas emerge from individuals, but their spread and refinement depend on networks. The larger and more interconnected the network, the faster beneficial innovations can propagate. The more paths there are for information to flow, the less likely it is that useful knowledge will be lost. The archaeological record bears this out. The Mousterian tool tradition associated with Neanderthals is sophisticated. The Levallois technique for preparing stone cores and producing predetermined flakes represents a high level of planning and skill. These were not primitive tools, but the tradition was also stable. The same basic forms persist for tens of thousands of years across vast geographic ranges. Innovation occurred, but slowly. In contrast, when Homo sapiens entered Europe, they brought the Aurignacian industry, and the archaeological record shows much more rapid turnover in tool styles, more regional variation, more experimentation. This isn't because individual Homo sapiens were smarter than individual Neanderthals. It's because the social structure of Homo sapiens populations supported faster cultural accumulation. Larger groups, more connections between groups, more opportunities for ideas to spread and combine. This is the cognitive trade-off made visible in stone. Neanderthal minds were capable of complex planning and skilled execution, but their social organization, constrained in part by brain structure, limited the speed at which their culture could evolve. If Neanderthals had survived, this pattern would likely continue. Not unchanging, cultures adapt and develop even within constraints, but the underlying difference in social organization would persist, shaped by the biological reality of brain structure. In a modern context, this would manifest in several ways. Neanderthal communities might remain smaller, more localized. Their cultural products might emphasize depth over breadth, mastery of specific domains rather than broad eclecticism. Their approach to innovation might be more conservative, favoring refinement of existing practices over adoption of novelty. This isn't a moral judgment. There's no inherent superiority in cultural change versus cultural continuity. Different strategies succeed in different contexts, but in a world where two human species coexist, the difference would be visible. Institutions built around Homo sapiens assumptions about group size, about the speed of information exchange, about the value placed on novelty, these institutions might not serve Neanderthal populations well. And the reverse would also be true. Structures that Neanderthals developed, emphasizing tight social bonds, long-term continuity, mastery of specific environments, might feel constraining or parochial to Homo sapiens, accustomed to larger, more fluid networks. The cognitive differences between the species wouldn't make coexistence impossible, but they would make it complicated, requiring constant negotiation, constant adaptation of social structures to accommodate two distinct ways of organizing thought and relationship. The trade-offs made in the Pleistocene would echo forward, shaping the texture of daily life in the present. For much of the 20th century, Neanderthals were depicted as brutish, cognitively limited, capable of survival but lacking the spark of full humanity. This image persisted in popular imagination even as the evidence against it accumulated. The archaeological record, examined carefully and without prejudice, tells a different story. It reveals a species with symbolic thought, cultural complexity, and the capacity for behaviors that define what we recognize as human. The clearest evidence comes from cave art. In northern Spain, at sites like La Pasiega, Maltravieso, and Ardales, Paintings adorn the walls deep within the rock. Simple geometric forms, handprints, abstract designs. For a long time, these were assumed to be the work of Homo sapiens, part of the great flowering of Upper Paleolithic art that includes the famous images at Lascaux and Altamira. But uranium-thorium dating, a technique that measures the age of the mineral deposits that form over the paintings, revealed something unexpected. Some of these images were older than the arrival of Homo sapiens in Europe, significantly older. The paintings at La Pasiega, including a distinctive ladder-shaped symbol, date to more than 64,000 years ago. At that time, Neanderthals were the only hominins in the region. This dating pushed the origins of symbolic art back beyond the Homo sapiens lineage. It established that the capacity for creating abstract visual symbols, for marking surfaces with intentional designs that convey meaning beyond their literal appearance, was not unique to our species. It was shared, inherited from a common ancestor, or independently derived in both lineages. The implications are significant. Symbolic thought is often considered the hallmark of modern human cognition. It underlies language, art, religion, all the complex cultural systems that distinguish human societies from those of other animals. If Neanderthals possessed this capacity, then they were not cognitively separated from Homo sapiens by some fundamental gulf. They were different in organization, as discussed in previous chapters, but not in kind. Their technological sophistication supports this conclusion. The Mysterian tool industry, the characteristic stone tool tradition associated with Neanderthals, shows a high degree of planning and skill. The Levallois technique is particularly telling. It involves preparing a stone core through a series of careful strikes, shaping it so that a final blow will detach a flake of predetermined size and form. This isn't trial and error. It requires holding a mental image of the desired outcome and executing a precise sequence of actions to achieve it. The resulting tools, sharp flakes and points, were not simply handheld. Evidence shows that many were hafted, attached to wooden handles or shafts using bindings and adhesives. This transforms a sharp stone into a composite tool, a spear or a knife, extending the reach and effectiveness of the user. Creating such tools requires multiple steps, gathering different materials, processing them, assembling them. It's a technological system, not just a single innovation. Some of the pointed tools were designed as projectiles or stabbing weapons. This suggests strategic thinking about hunting, about how to engage dangerous prey while minimizing risk. The Neanderthal approach to hunting was close range, but it wasn't reckless. It was planned, using tools specifically designed for the task. Beyond technology, the treatment of the dead provides perhaps the most direct evidence of symbolic and social complexity. Neanderthals buried their dead. Not in all cases, and not always with the elaborate grave goods that appear in later Homo sapiens burials. But the practice existed. Bodies were placed in intentional graves, sometimes within caves, in locations that seem to have been chosen deliberately. At Shanidar Cave in Iraq, a series of Neanderthal burials have been excavated over several decades. One of the most debated findings is the presence of pollen from flowers in the soil surrounding some of the bodies. If this pollen represents intentional offerings, flowers placed with the dead, it would indicate a ritual practice, an awareness of death as something requiring ceremony. The interpretation of the Shanidar flower pollen remains contentious. Pollen can enter a site through many routes: wind, animal activity, water flow. Proving intentional placement is difficult, but even setting that question aside, the deliberate burial itself is significant. It represents a recognition that the dead are different from the living, that bodies require special treatment, that there's meaning in how a community handles the transition from life to death. Other burials show similar care. Bodies are positioned, sometimes in flexed postures, that would require deliberate arrangement. Stones are occasionally placed near or on the body. These acts take effort. They serve no obvious practical purpose. Their function is symbolic, reflecting beliefs about death, about the individual, about the community's relationship to the deceased. Perhaps the most profound evidence of Neanderthal humanity comes not from graves, but from the living. At Shanidar Cave, among the burials, researchers found the remains of an adult male with extensive injuries and disabilities. His right arm was withered, likely from a birth defect or early injury. He was deaf. He had sustained trauma that left him partially blind. By all indications, he lived with these disabilities for decades, reaching an age that was old by Neanderthal standards. This individual could not have survived alone. He couldn't hunt effectively. He couldn't hear approaching danger. He required support from his community, care that continued year after year without any direct practical benefit to those providing it. His survival is evidence of compassion, of social bonds that transcended immediate utility, of a moral framework that valued individuals even when they couldn't contribute to subsistence. This isn't unique. Other Neanderthal sites show evidence of healed injuries, conditions that would have been debilitating during recovery. Broken bones that mended, infections that resolved, wounds that closed. Each case represents care, someone bringing food, defending the injured, maintaining social bonds during vulnerability. These behaviors, art, complex technology, burial, long-term care of the disabled, these are the markers by which we recognize personhood. They demonstrate self-awareness, recognition of others as beings with interior lives, capacity for empathy and abstract thought. The Neanderthals were not proto-humans struggling toward consciousness. They were people, fully realized, with cultures as rich and meaningful as those of any early Homo sapiens group. If they had survived, this would not be a matter of historical curiosity. It would be a legal and ethical fact demanding recognition. Any framework of rights or personhood that claims to be based on cognitive capacity, on moral awareness, on the ability to suffer and to care, would have to extend to Neanderthals. There would be no principled basis for exclusion. Their extinction, therefore, is not a story about the triumph of superior intelligence. It's a story about ecology, about competition for resources, about demographic dynamics and environmental change. It's a loss, the disappearance of a lineage that was fully, completely human in all the ways that matter. And contemplating their survival means contemplating a world where that loss never occurred, where the symbolic minds that painted caves and buried their dead with care continued forward, generation after generation, into the present. The Shanidar cave site in the Zagros Mountains of Iraq has yielded some of the most compelling evidence for the depth of Neanderthal social life. The cave was occupied intermittently over tens of thousands of years, and within its deposits, archaeologists have found the remains of at least 10 Neanderthal individuals. Several of these were intentional burials, but one individual in particular stands out, not for how he died, but for how he lived. Shanidar I, as he's known in the literature, was an adult male who survived to approximately 40 to 50 years of age. In Neanderthal terms, this was old. Life expectancy was short, not because of any inherent frailty, but because of the constant physical demands and risks of their existence. Reaching middle age was an achievement, but Shanidar I reached that age despite profound disabilities. His right arm was withered and deformed. The bone structure indicates the condition was long-standing, possibly present from birth or resulting from an injury sustained in early childhood. The arm would have been largely useless, unable to bear weight or grip tools effectively. He was also deaf. Damage to the ear canal, preserved in the fossilized bone, shows signs of an infection or injury that would have destroyed his hearing, and he had sustained a severe blow to the left side of his head at some point in his life, trauma that likely resulted in partial blindness and possibly other neurological impairments. These are not minor injuries. Taken together, they would have made independent survival nearly impossible. Hunting requires coordination, strength, hearing, vision. Neanderthal hunting was close range, dangerous, involving large animals that could easily kill an adult human. An individual who couldn't use one arm, couldn't hear predators or threats approaching, couldn't see clearly, would be a liability in such activities. Yet Shanidar I lived for years, possibly decades, with these disabilities. The bones show healing. He survived long enough after his injuries for the bone to remodel, for the body to adapt to its changed state. This didn't happen in isolation. It required his community to provide for him. Food, protection, inclusion in the social group, despite his inability to contribute directly to hunting or defense. This is care in the deepest sense, not the immediate reciprocity of mutual aid, where help is given with the expectation of return. This was ongoing support for an individual who by purely practical measures was a drain on resources. The community kept him alive because he mattered to them, because whatever bonds connected them to him persisted, even when the practical reasons for maintaining those bonds had disappeared. Other Neanderthal sites show similar patterns. La Chapelle-aux-Saints in France yielded the skeleton of an elderly male with severe arthritis and almost complete loss of teeth. Chewing would have been difficult. Hard foods, raw meat, these would have been nearly impossible for him to process. Yet he lived to old age. Someone must have prepared softer foods, perhaps pre-chewing meat, certainly selecting resources that could be consumed despite his condition. At Krapina in Croatia, remains show healed fractures, injuries that would have been incapacitating during recovery. Broken legs, fractured ribs, damage that requires weeks or months of limited mobility to heal. Each case represents a period where the injured individual needed to be fed, protected, included, without being able to fully participate in the activities of daily survival. The consistency of this evidence across different sites and time periods suggests that care for the injured and disabled was not exceptional. It was part of the social fabric. Neanderthal communities expected to support their members through injury and aging. They had social structures that accommodated dependence, that distributed resources to those who couldn't acquire them independently. This has profound implications for understanding Neanderthal social organization. Caregiving requires surplus, a community operating at the edge of survival, where every individual must contribute maximally just to maintain the group, cannot afford to support non-contributors. The fact that Neanderthals could and did provide long-term care indicates they achieved levels of resource extraction sufficient to create that surplus. It also indicates emotional and cognitive complexity. Care requires empathy, the ability to recognize suffering in another and be motivated to alleviate it. It requires theory of mind, understanding that others have internal experiences analogous to one's own. And it requires a social framework that values individuals beyond their immediate utility, that sees worth in persons rather than just in functions. These are the same cognitive and emotional capacities that underlie moral reasoning. The recognition of others as subjects, as beings whose welfare matters, is the foundation of ethics. Neanderthals demonstrated this capacity through their actions, preserved in bone and burial, in the patterns of healed injury and prolonged survival despite disability. If Neanderthals had survived into the modern era, this history of compassion would be part of their cultural inheritance. It would be evidence, undeniable and documented, that their capacity for moral thought and social care matched that of Homo sapiens. Any legal or philosophical system that tried to classify them as less than persons, as beings without moral standing, would have to ignore or dismiss this evidence. But beyond the legal implications, the evidence from Shanidar and similar sites reveals something about the nature of humanity that transcends species. Compassion, the willingness to care for others at cost to oneself, is not unique to Homo sapiens. It's older. It existed in the common ancestor we shared with Neanderthals, or it emerged independently in both lineages. Either way, it's a fundamental feature of human social life, not an invention of modern culture, but a deep pattern woven into the structure of hominin sociality. This matters for how we think about the past and the hypothetical present we're constructing. If Neanderthals had survived, they wouldn't be alien others, fundamentally incomprehensible. They would be kin in the deepest sense. Different in body and in some aspects of cognition, yes, but similar in the ways that matter most for moral community. They cared for their injured. They mourned their dead. They lived in networks of mutual dependence and support. A world with two human species would be a world with two populations sharing not just intelligence, but also the emotional and ethical foundations that make social life possible. The challenges of coexistence wouldn't arise from one species being persons and the other not. They would arise from the mundane but difficult work of accommodating difference within a shared framework of mutual recognition. The disabled man at Shanidar lived because his community valued him. His survival is a gift across time, evidence that reaches forward to inform how we understand what humanity means. Not perfection, not dominance, not even intelligence in the abstract, but care. The simple profound act of keeping someone alive because they matter. That capacity, preserved in 40,000-year-old bones, is the foundation on which any shared future between two human species would have to be built. Approximately 45,000 years ago, the human geography of Eurasia shifted. Homo sapiens, who had evolved in Africa and spent tens of thousands of years expanding across that continent, began moving northward and westward into territories that had been occupied by Neanderthals for hundreds of thousands of years. This wasn't an invasion in any military sense. There were no armies, no organized campaigns of conquest. It was migration, the slow movement of populations following resources, exploring new territories, settling in favorable locations. But it was also the beginning of contact between two human species that had been separated for more than 500,000 years. The Neanderthals weren't newcomers to these lands. Their ancestors had been present in Europe and Western Asia since the Middle Pleistocene, adapting to the cycles of glaciation and warming that characterized the Ice Age. They knew these environments intimately. Their technology, their hunting strategies, their seasonal movements, all of this was calibrated to the specific demands of Eurasian ecology. Homo sapiens arrived as outsiders, adapted to different climates and resources. Their evolution had occurred primarily in Africa, under different selective pressures. They were more gracile, better suited to endurance rather than power, accustomed to warmer climates and more diverse diets. But they were also flexible, capable of learning and adapting, able to modify their strategies to fit new conditions. The two populations overlapped for a considerable period. In Europe, the cohabitation lasted somewhere between 2,600 and 5,400 years. This is not a trivial span. It's longer than recorded history. It's enough time for dozens of generations, for the establishment of territories, for the development of relationships, both cooperative and competitive. In Asia, the overlap may have been even longer. Some estimates suggest interactions spanning up to 20,000 years, though the evidence is sparser and more difficult to interpret. The Asian landmass was vast, supporting multiple populations in different ecological zones. Contact wouldn't have been constant or uniform. In some regions, the two species might have coexisted closely. In others, they might have rarely encountered each other, separated by distance or by occupation of different resource niches. What happened during this long overlap is a matter of careful reconstruction from limited evidence. The populations left traces, stone tools, hearth sites, occasional skeletal remains. From these fragments, researchers have pieced together a picture of contact that was complex, varied, and consequential. One thing is clear. The two species were aware of each other. They occupied the same landscapes, hunted the same prey, used the same caves and rock shelters. They would have encountered each other's camps, seen each other's tool-making debris, perhaps observed each other from a distance. In some cases, they must have come into direct contact. The nature of those contacts is harder to determine. Were they hostile, cooperative, indifferent? The answer is probably all of these, depending on circumstances. Human behavior, even within a single species, varies enormously based on context. When resources are abundant, tolerance is easier. When they're scarce, competition intensifies. The same pattern likely held for interactions between Neanderthals and Homo sapiens. There's no clear archaeological evidence for organized violence between the groups. No mass graves showing battle casualties, no fortifications designed to keep one group out. This doesn't mean violence never occurred. Individual conflicts, raids, territorial disputes. These leave little trace in the archaeological record, but it does suggest that sustained, large-scale warfare wasn't the defining feature of their interaction. Instead, what the evidence shows is something more subtle: cultural exchange, the transmission of ideas and techniques across the species boundary. This is visible in the stone tools. When Homo sapiens first arrived in Europe, they manufactured tools that were in many cases similar to the Mousterian tradition used by Neanderthals. They produced simple flakes and scrapers using techniques that closely resembled those of the local Neanderthal populations. This similarity suggests learning, either through direct observation or through some form of teaching. At the same time, Neanderthal sites from the latest period of their existence show changes. New tool forms appear, innovations that weren't part of the traditional Mousterian repertoire. Some of these resemble the more advanced technologies associated with Homo sapiens. The implication is that Neanderthals were adopting techniques from the newcomers, incorporating new ideas into their existing practices. This kind of cultural exchange requires more than just observation. It suggests a degree of tolerance, a willingness to learn from the other group, rather than simply avoiding or attacking them. It indicates that, at least in some times and places, the two populations coexisted peacefully enough for information to flow between them. The archaeological transition that marks the end of this period is dramatic. Between 39,000 and 41,000 years ago, the Mousterian industry largely disappears from the European record. It's replaced almost entirely by the Aurignacian tradition, the stone tool industry associated with Homo sapiens. This replacement is rapid, occurring over just a few thousand years, a geological instant. The interpretation of this transition has been debated for decades. Some researchers saw it as evidence of Neanderthal cognitive inferiority, an inability to compete with the superior technology and intelligence of Homo sapiens. But that interpretation doesn't fit the evidence we've discussed. Neanderthals were cognitively sophisticated, capable of symbolic thought and complex technology. A more nuanced understanding recognizes that the competitive advantage wasn't individual intelligence, it was systemic. Homo sapiens' social organization, characterized by larger group sizes and more extensive networks between groups, created a cultural engine that operated differently. Information spread faster. Innovations could be tested, refined, and transmitted more quickly across a larger population. This doesn't require any individual Homo sapiens to be smarter than any individual Neanderthal. It's an emergent property of social structure. Over time, this systemic advantage compounded. The rate of cultural accumulation accelerated in Homo sapiens populations, while remaining more stable in Neanderthal groups. New techniques, new strategies, new ways of extracting resources from the environment. These appeared and spread more rapidly among Homo sapiens. In a landscape where both species were competing for the same resources, this mattered. Not immediately, not in any single generation, but over millennia, the cumulative effect was significant. Homo sapiens populations could adapt more quickly to changing conditions, could exploit resources more efficiently, could maintain larger populations in the same territory. The long overlap, then, was a period of coexistence, but not stasis. It was dynamic, characterized by exchange and learning, but also by gradual shifts in the competitive balance. The two species shared the landscape for thousands of years, but the conditions were slowly tilting in favor of one over the other. If Neanderthals had survived, it would mean this tilting somehow halted or reversed. Perhaps climate conditions shifted in ways that favored their adaptations. Perhaps they adopted enough of the Homo sapiens social innovations to level the competitive field. Perhaps geographic separation allowed both populations to persist in different regions, reducing direct competition. But in the world that actually unfolded, the overlap was finite. The period of coexistence ended not with a bang, but with a fade, Neanderthal populations declining gradually, their territories shrinking, their numbers dwindling, until the last communities disappeared entirely. Understanding why that happened requires looking more closely at the mechanisms of competition and the specific vulnerabilities that made Neanderthal populations fragile, in ways that Homo sapiens populations were not. The archaeological record of the late Middle Paleolithic and early Upper Paleolithic reveals something unexpected about the relationship between Neanderthals and Homo sapiens. Despite their long separation and distinct evolutionary histories, the two species didn't maintain rigid cultural boundaries. Instead, they learned from each other, adopting techniques and possibly behaviors across the species divide. This cultural transmission is most visible in stone tools, the most durable artifacts left behind. Tools don't decay the way organic materials do. They remain in the archaeological record, allowing researchers to trace changes in manufacturing techniques across time and space. And those changes tell a story of contact and influence. When Homo sapiens first entered Europe from Western Asia, their toolkits weren't radically different from what Neanderthals were already producing. Early Homo sapiens sites show simple flakes, scrapers, and points manufactured using techniques that closely parallel the Mousterian tradition. The Levallois method, that careful preparation of a core to produce predetermined flakes, appears in both Neanderthal and early Homo sapiens assemblages in overlapping territories. This similarity could theoretically be coincidence, both groups independently arriving at similar solutions to the problem of making sharp-cutting tools. But the geographic and temporal pattern argues against that. The resemblance is strongest in regions where the two species overlapped, and it occurs during the period of cohabitation. The simplest explanation is that Homo sapiens, arriving in unfamiliar territory, observed and adopted techniques that Neanderthals had been using successfully for millennia. This makes practical sense. The Mousterian technology was effective. It had been refined over hundreds of thousands of years to suit the specific types of stone available in European environments and the kinds of tasks required for Ice Age survival. A newly arrived population would benefit from incorporating that local knowledge rather than relying solely on techniques developed in different contexts. But the transmission wasn't unidirectional. Neanderthal sites, from the latest phase of their existence, the final few millennia before their disappearance, show innovations that don't fit the traditional Mousterian pattern. At some sites, archaeologists have found more sophisticated bone tools, ornamental objects, and tool forms that resemble those associated with Homo sapiens' Upper Paleolithic traditions. The site of Arcy-sur-Cure in France provides a particularly interesting case. The assemblage includes ornamental items, pierced animal teeth that could have been worn as pendants, and bone tools with careful shaping. These objects are associated with Neanderthal remains, not Homo sapiens. They date to the transitional period, when both species were present in Europe. The interpretation of sites like Arcy has been contentious. Some researchers suggested that Neanderthals simply scavenged these objects from Homo sapiens sites, incorporating them without understanding their manufacture or significance. But that explanation seems unnecessarily dismissive. Neanderthals had demonstrated symbolic capacity in their cave art and burial practices. There's no reason to assume they couldn't understand or create ornamental objects themselves. A more parsimonious interpretation is that Neanderthals saw Homo sapiens creating these objects and adopted the practice themselves. This isn't imitation without comprehension, it's cultural learning, the same process by which all human populations acquire new techniques. You observe, you experiment, you incorporate what works into your existing repertoire. The presence of cultural exchange indicates several things about the nature of contact between the species. First, it means there was opportunity for observation. The groups were close enough, interacting frequently enough, that techniques could be transmitted. Second, it suggests a degree of tolerance. Cultural learning is difficult in an environment of constant hostility. You can't carefully observe another group's technology if every encounter results in violence. Third, and perhaps most significantly, it demonstrates that both species recognize something in the other. They saw tool-making behavior and understood it as analogous to their own practices. They recognized intention, skill, the possibility of improvement through adoption of new methods. This is sophisticated social cognition. It requires seeing the other not as mere animal or object, but as an agent, a being whose actions have purpose and can be learned from. Despite this mutual exchange, the overall trajectory was toward replacement. The Mousterian tradition, which had dominated Europe for hundreds of thousands of years, was supplanted by the Aurignacian industry between 39 and 41,000 years ago. This transition was relatively rapid and geographically widespread. The Aurignacian is characterized by different manufacturing techniques, a broader range of tool types, and more standardized forms. It includes sophisticated bone and antler tools, not just stone. It's associated with art, personal ornaments, and what appears to be more complex social organization. In short, it's a distinct cultural package, one that became dominant across Europe in a relatively short period. The traditional interpretation was that this replacement reflected cognitive superiority, that Homo sapiens simply outthought Neanderthals, and their superior culture inevitably prevailed. But that explanation doesn't account for the evidence of Neanderthal symbolic and technological sophistication. It also doesn't explain why, if Neanderthals were incapable of cultural complexity, they were able to adopt some Upper Paleolithic innovations during the transitional period. A more sophisticated understanding recognizes that the advantage wasn't cognitive. capacity but cultural transmission dynamics. Homo sapiens populations were organized in ways that facilitated faster accumulation and spread of innovations. Their larger social networks meant more minds working on problems, more opportunities for good ideas to spread, more paths for information to flow. Neanderthal populations, operating in smaller groups with less connectivity between communities, couldn't match this rate of cultural evolution. They were capable of innovation, capable of learning. But the structure of their society limited how quickly those innovations could spread and compound. Over time, this difference in cultural dynamics translated into a competitive advantage. Homo sapiens groups developed more efficient hunting techniques, better tools, more effective resource extraction strategies, not because any individual was more intelligent, but because the system they were embedded in generated and distributed innovations more rapidly. In a landscape of shared resources and overlapping territories, this mattered. Homo sapiens populations could support higher densities, exploit a wider range of foods, respond more flexibly to environmental changes. Neanderthal populations, constrained by their social structure and their more specialized subsistence strategies, faced increasing pressure. The cultural exchange visible in the archaeological record, then, wasn't enough to overcome the deeper structural differences. Neanderthals could adopt specific techniques from Homo sapiens, but they couldn't easily adopt the social organization that made those techniques part of a rapidly evolving cultural system. If Neanderthals had survived, it would have required either a fundamental shift in their social structure, moving toward larger, more connected groups, or it would have required geographic or ecological separation sufficient to reduce direct competition. The exchange of ideas would have continued, likely accelerating over time as contact increased. But for both species to persist, there would need to be either complementary niches, each population specializing in different resources or environments, or a deliberate cultural decision to maintain separation and respect territorial boundaries. In the historical reality, neither occurred. The overlap continued, the competition intensified, and eventually the Neanderthal populations declined to extinction. But the evidence of cultural exchange remains, testament to the fact that for thousands of years, two human species shared knowledge across the boundary of biology, recognizing in each other something worth learning from. The disappearance of Neanderthals as a distinct population didn't mean their genetic contribution vanished entirely. DNA analysis, developed long after the last Neanderthal bones were excavated, revealed something unexpected. The species left a legacy written into the genomes of living humans. The first complete Neanderthal genome was sequenced in the early 21st century, extracted from fossilized bones tens of thousands of years old. The technical achievement was remarkable in itself, recovering and reconstructing genetic information from degraded ancient material. But the real surprise came when researchers compared that ancient genome to the genomes of living human populations. They found Neanderthal DNA in modern humans, not in everyone. African populations, whose ancestors never left the continent during the period of overlap, showed little to no Neanderthal ancestry. But populations with recent ancestry from Europe, Asia, and the Americas, descended from groups that passed through or settled in the regions where Neanderthals lived, all carried Neanderthal genetic variants. The proportion wasn't large. Estimates settled around 1 to 4% of the genome in non-African populations. But that small percentage was significant. It meant that interbreeding had occurred. Homo sapiens and Homo neanderthalensis, despite hundreds of thousands of years of separate evolution, were still compatible enough to produce viable, fertile offspring. The interbreeding wasn't a single event. Genetic analysis revealed multiple episodes of admixture occurring at different times and places. The estimates placed these events between 47,000 and 65,000 years ago, during the period when Homo sapiens was migrating into Eurasian territories and beginning to overlap with Neanderthal populations. The exact circumstances are impossible to reconstruct. Were these consensual relationships, pair bonds between individuals from different populations? Were they violent encounters? Were there sustained communities where both species lived together, or were these occasional contacts at the edges of territories? The DNA can't answer those questions. It records the fact of genetic exchange, but not the context. What the DNA can reveal is which parts of the Neanderthal genome persisted in the Homo sapiens lineage, and which parts were lost, This distribution isn't random. Natural selection has been acting on these archaic genetic variants for tens of thousands of years, retaining what was beneficial and eliminating what was harmful. The retained Neanderthal variants cluster in certain functional categories. A significant number affect skin and hair biology, specifically genes involved in producing keratin, the protein that forms the structural basis of skin, hair, and nails. This makes adaptive sense. Neanderthals evolved in northern latitudes with different UV exposure and temperature conditions than those in Africa. Genetic variants that helped them adapt to those conditions would also benefit Homo sapiens populations moving into the same regions. The Neanderthal ancestry also contributed to immune system function. Several genes involved in recognizing and responding to pathogens show Neanderthal origin. Again, this makes sense. Neanderthals had been living in Eurasia for hundreds of thousands of years, exposed to local diseases, evolving immune responses specific to those challenges. When Homo sapiens arrived from Africa, they encountered new pathogens. Acquiring immunity genes from a population that had already adapted to those diseases would provide immediate benefits. But not all Neanderthal DNA was advantageous. The distribution shows clear patterns of depletion in certain regions of the genome. Neanderthal ancestry is conspicuously low on the X chromosome, one of the two sex chromosomes. It's also reduced in genes, specifically expressed in the testes, genes involved in male reproductive function. This pattern is characteristic of what geneticists call hybrid incompatibility. When two populations have been separated for a long time, genetic differences accumulate. Most of these differences are neutral, neither beneficial nor harmful, but some affect the complex developmental processes involved in reproduction. When individuals from the two populations interbreed, some combinations of genes don't work well together. Hybrid offspring may have reduced fertility, particularly in the heterogametic sex, the sex with two different sex chromosomes. In mammals, that's males. The depletion of Neanderthal DNA in male fertility genes suggests that hybrid males had reduced reproductive success. They may have been less fertile or entirely sterile, or they may have died before reaching reproductive age. Over generations, natural selection would eliminate the genetic variants causing these problems, resulting in the observed pattern of depletion. This has a profound implication. Homo sapiens and Homo neanderthalensis were at the edge of biological compatibility. They could interbreed, the offspring could survive, some were fertile, but there were costs, genetic incompatibilities that reduced fitness. Given more time, given continued separation, these incompatibilities would have deepened, eventually making viable hybrids impossible. The species were diverging toward complete reproductive isolation. If Neanderthals had survived, this incompatibility would remain. It wouldn't disappear simply through continued contact. The genetic basis is too fundamental, too deeply embedded in the developmental systems that build reproductive tissues. Continuous interbreeding would still produce some individuals with reduced fertility. Hybrid males would still face higher risks of sterility. In a modern context, this would require social and medical responses. Couples from the two species choosing to have children together would need genetic counseling, assessment of compatibility risk, possibly reproductive technologies to overcome fertility barriers. The biological boundary between the species would be an inescapable fact, shaping personal decisions and requiring institutional accommodations. The Neanderthal genetic legacy also carries medical implications for modern humans. Some of the retained variants, while perhaps beneficial in Ice Age environments, contribute to disease susceptibility in contemporary populations. Specific Neanderthal alleles have been associated with increased risk for type 2 diabetes, for certain autoimmune disorders including Crohn's disease and lupus, and for conditions affecting skin such as increased formation of keratosis. These associations don't mean Neanderthal DNA is inherently pathological. It means that genes optimized for one environment and lifestyle don't necessarily function optimally in different conditions. A variant that helped regulate fat metabolism efficiently in a high-protein, low-carbohydrate Ice Age diet might contribute to metabolic dysfunction in a modern diet high in processed carbohydrates. The genes haven't changed, the context has. If living Neanderthal populations existed today, medical research would need to account for species-specific differences in disease risk, drug response, nutritional requirements. A medication optimized for Homo sapiens metabolism might be less effective or more toxic in Neanderthals. Dietary guidelines would need separate recommendations. The entire infrastructure of medicine and public health, built around the assumption of a single human species, would require fundamental restructuring. The genetic echo that 1 to 4% of archaic DNA still present in most living humans is more than historical curiosity. It's functional biology, affecting health and development in measurable ways. It connects the present to the deep past, makes Neanderthals not just extinct relatives, but ongoing participants in human biology. And it establishes that the boundary between species, while real, is permeable. Genetic material crossed that boundary tens of thousands of years ago and persists today. The two lineages weren't isolated by absolute reproductive barriers. They were distinct but connected, separate but capable of exchange. That pattern, if both species had survived, would continue, creating a complex genetic landscape where most individuals were clearly one species or the other, but some carried mixed ancestry, and everyone navigated the reality of partial biological compatibility constrained by real incompatibility costs. The evidence of interbreeding establishes that Neanderthals and Homo sapiens were capable of producing offspring together. But the pattern of genetic inheritance, particularly the depletion of Neanderthal ancestry, in genes related to male fertility, reveals something equally important. The two species were approaching the limits of reproductive compatibility. Understanding this requires some background on how species boundaries work at the genetic level. When populations are part of the same species, gene flow occurs freely. Individuals from different groups can mate and produce fully fertile offspring, who themselves can reproduce without difficulty. Genetic variants spread across the population, homogenizing it to some degree, preventing the accumulation of incompatibilities. When populations become separated, geographically or ecologically, gene flow stops. Each population begins accumulating its own mutations, its own genetic changes. Most of these are neutral, neither beneficial nor harmful. But over time, the two gene pools diverge. Eventually, enough differences accumulate that the genomes become incompatible. The incompatibilities typically manifest in hybrid offspring. The two parental genomes each evolved independently, optimized for their own internal consistency. When combined in a hybrid, the resulting genome contains pieces that don't work well together. This is particularly problematic in complex developmental processes, like the formation of reproductive organs and the production of gametes. A common pattern, seen across many animal species, is that hybrid males are more affected than hybrid females. This is known as Haldane's rule, named after the geneticist who first described it. The explanation relates to sex chromosomes. In mammals, males have one X and one Y chromosome, while females have two X chromosomes. If there are incompatibilities involving X-linked genes, males have no backup copy. A problematic variant on the single X chromosome will be expressed, while females with two X chromosomes can often compensate. The genetic data from modern humans shows exactly this pattern with Neanderthal ancestry. The X chromosome has significantly less Neanderthal DNA than would be expected by chance. Genes expressed specifically in the testes also show strong depletion. These are the signatures of selection against hybrid incompatibility, specifically affecting male fertility. This means that in the population of hybrids produced when Neanderthals and Homo sapiens interbred, male offspring likely had reduced fertility. Some may have been entirely sterile. Others may have had low sperm counts or other reproductive impairments that made successful reproduction less likely. Over generations, natural selection eliminated the specific genetic combinations causing these problems, resulting in the patterns we observe today. Female hybrids, less affected by these X-linked incompatibilities, would have been more fertile. The Neanderthal DNA that persists in modern humans passed primarily through female lineages in the generations immediately following admixture. This created a bias. We retain the Neanderthal variants that functioned adequately in female reproductive biology, while losing those that caused problems in males. The important point is that this isn't ancient history with no modern relevance. These incompatibilities weren't resolved. They weren't fixed by the limited interbreeding that occurred. The two species remained genetically distinct populations, and the biological barriers to complete merger remained in place. If Neanderthals had survived as a distinct population, these barriers would still exist. Tens of thousands of additional years wouldn't change the fundamental incompatibilities that were already present 40,000 years ago. If anything, continued separation might have deepened them. What would this mean in practical terms? It would mean that relationships between the two species, while possible, would carry biological costs. Couples choosing to have children would face the risk that male offspring might be infertile or subfertile. This isn't a small concern. It's a fundamental issue affecting reproductive autonomy and family planning. Modern reproductive medicine could potentially mitigate some of these problems. Genetic screening could identify couples at higher risk. Assisted reproductive technologies, in vitro fertilization with genetic selection of embryos, could potentially reduce the incidence of hybrid sterility. But these are complex, expensive interventions. They represent a barrier that same-species couples wouldn't face. There would also be deeper questions about the ethics of such interventions. If two species can interbreed, but the offspring face significant health risks, does that constitute a reason to discourage interspecies relationships? Or does reproductive autonomy mean individuals have the right to accept those risks if they choose? These aren't abstract philosophical questions. They're practical dilemmas that would require social and legal frameworks to address. The biological boundary would also ensure that despite millennia of potential contact and interbreeding, Neanderthals and Homo sapiens would remain distinct. The genetic incompatibilities act as a barrier to complete assimilation. Even with frequent interbreeding, the populations would maintain separate identities. You wouldn't see a gradual blending into a single intermediate form. You'd see two populations, clearly distinct, with some mixed ancestry individuals, but predominantly maintaining their separate genomic integrity. This is different from variation within a species. Modern Homo sapiens shows tremendous genetic diversity across populations. African, European, Asian, Native American populations have distinct genetic profiles, but they're all fully interfertile. No hybrid incompatibilities prevent gene flow. A child with parents from any two human populations will have normal fertility. That wouldn't be true for Neanderthal sapiens hybrids. The incompatibilities would persist, generation after generation, maintaining the boundary between species even in the face of cultural integration and shared geography. The genetic architecture underlying these incompatibilities is complex. It's not a single gene or a simple trait. It's the cumulative effect of many small differences scattered across the genome, each individually minor but collectively significant. This means there's no straightforward fix, no single genetic modification that could remove the barrier. What we're describing is the biological reality of being separate species, not different races or populations within a species, but distinct evolutionary lineages that have accumulated enough differences to create reproductive barriers. Those barriers aren't absolute. They don't prevent all interbreeding, but they're real, consequential, and permanent. If Neanderthals had survived, this biological boundary would be one of the defining facts of interspecies relations. It would ensure that despite living side by side, despite cultural exchange, despite individual relationships and mixed families, the two populations would remain two populations. The boundary would be visible not just in physical appearance, but in the fundamental biology of reproduction. This persistence of distinction matters for how we think about a world with two human species. It wouldn't be a world trending toward unity, toward eventual merger into a single hybrid population. It would be a world of permanent biological duality. Two lineages sharing the planet, but constrained by the limits of genetic compatibility to remain forever separate, connected by history and by the small percentage of shared ancestry, but divided by the deeper incompatibilities that mark them as distinct species. The question of why Neanderthals went extinct while Homo sapiens survived has been debated for over a century. Early theories attributed it to cognitive inferiority, to an inability to compete intellectually with modern humans. But as we've established, that explanation doesn't fit the evidence. Neanderthals were cognitively sophisticated, capable of symbolic thought, complex technology, and compassionate social organization. The answer lies not in intelligence but in ecology. specifically in the interaction between Neanderthal biological specialization and the environmental conditions of the late Pleistocene, the period when the two species overlapped in Eurasia. The late Pleistocene was characterized by dramatic climate instability. This wasn't a gradual cooling or warming trend, it was a period of rapid oscillations between different climate states. Within spans as short as a few decades or centuries, conditions could shift from cold, dry tundra to wetter grassland to sparse woodland and back again. These shifts were driven by complex interactions between ocean currents, ice sheet dynamics, and atmospheric circulation patterns. For animal populations, particularly large herbivores, these rapid climate changes created boom and bust cycles. During favorable periods, populations expanded rapidly. Grassland supported large herds of bison, horses, and deer. But when conditions shifted unfavorably, those populations crashed. Plant communities changed, preferred forage became scarce, and herbivore numbers plummeted. Neanderthals, as we've established, were heavily dependent on hunting these large herbivores. Their robust build, their high caloric requirements, their specialized hunting strategies, all of this was optimized for extracting protein and fat from megafauna. In stable, resource-rich environments, this strategy worked well. They were effective hunters, capable of reliably bringing down large, dangerous prey. But the late Pleistocene wasn't stable. The rapid climate oscillations meant that the herbivore populations Neanderthals depended on were themselves unstable. A decade of good conditions could support healthy Neanderthal populations. Then the climate would shift, herbivore numbers would crash, and suddenly the food supply was insufficient. A specialized diet provides little buffering against such volatility. If your primary caloric source becomes scarce, you need alternatives. The more specialized you are, the fewer alternatives exist. Neanderthals in northern latitudes had focused their subsistence strategies on large game to such a degree that when those resources failed, they had limited fallback options. The isotopic analysis of Neanderthal bones supports this picture. The nitrogen isotope ratios in their tissues indicate a diet very high in animal protein, comparable to apex carnivores like wolves. This isn't necessarily problematic in itself. Many human populations, historical and contemporary, have relied heavily on animal resources. The Inuit, for instance, traditionally consumed diets dominated by marine mammals and fish. But the Inuit example also illustrates an important point. Successful high-protein diets require reliable access to those protein sources or a diverse enough resource base to provide alternatives when preferred sources fail. The Inuit had access to multiple species, seals, walrus, fish, caribou, and they developed technologies and strategies to exploit all of them. Neanderthals, particularly in continental environments away from rich aquatic resources, may have had fewer options. Homo sapiens populations, in contrast, showed greater dietary flexibility. Archaeological sites associated with Homo sapiens from the same period reveal more varied food remains, evidence of fishing, of bird hunting, of plant processing, of small game exploitation. The isotopic signatures from Homo sapiens bones show lower reliance on large herbivores compared to contemporary Neanderthals. This doesn't mean Homo sapiens were better hunters or more intelligent about resource use. It means their subsistence strategy was broader, less specialized, more opportunistic. They could and did hunt large game when it was available, but they also invested effort in a wider range of food sources, many of which Neanderthals apparently underutilized. That flexibility became critical during periods of climate-driven resource scarcity. When large herbivore populations crashed, Homo sapiens could shift their focus to fish, to birds, to plant foods, to smaller mammals. Their caloric intake might decrease, conditions might be difficult, but they had options. Neanderthals, locked into their specialized strategy by both culture and by the demanding physiology of their robust bodies, faced harder choices. The caloric requirements matter here. A heavily muscled, cold-adapted body needs more energy to maintain. During resource scarcity, this becomes a liability. Homo sapiens, with their more gracile build and lower basal metabolic rate, could subsist on fewer calories. They could survive lean periods that might push Neanderthal populations beyond their tolerance. Demographic modeling supports this interpretation. when researchers simulate population dynamics under late Pleistocene conditions, incorporating realistic climate variability and species-specific traits, Neanderthal populations show higher volatility. They boom during good periods, but crash harder during downturns. Homo sapiens populations, with their broader resource base and lower per capita energy requirements, show more stable trajectories. Over time, this difference compounds. A single bad decade might not eliminate a Neanderthal population, but repeated cycles of boom and bust, each crash reducing numbers, each recovery incomplete, gradually erode the population base, and smaller populations are more vulnerable to the next crisis. There's also the issue of geographic range. Neanderthals, adapted to cold climates, were most successful in northern latitudes, but those northern ranges were also the areas most affected by glaciation and climate instability. During glacial maxima, much of northern Europe became uninhabitable, forcing populations southward into refugia. These ice-free zones were limited in extent, creating crowded conditions and intensifying resource competition. Homo sapiens, with their tropical origins and greater physiological flexibility, could occupy a wider range of environments. They weren't limited to the same refugia. They could exploit Mediterranean coastlines, penetrate into different ecological zones, maintain larger total population sizes distributed across more diverse habitats. The combination of dietary specialization, high energetic costs, and restricted geographic range created a demographic trap for Neanderthals. They weren't failing to adapt. They were adapted, highly so, but to conditions that were becoming increasingly unstable. Their adaptations, so effective during favorable periods, became liabilities when conditions shifted. The arrival of Homo sapiens added pressure to an already stressed system. Now Neanderthals weren't just competing against environmental challenges. They were competing against another human population for the same resources. A population that was more flexible, more widespread, present in higher numbers, and growing. The extinction didn't happen overnight. The process took thousands of years, playing out gradually as Neanderthal populations contracted, fragmented, and dwindled. The last known Neanderthal sites date to around 40,000 years ago, perhaps slightly later in some southern refugia. By 39,000 years ago, they were gone entirely from the archaeological record. If Neanderthals had survived, something in this dynamic would have had to change. Either the climate would have had to stabilize, providing the consistent resource base their specialization required, or they would have had to fundamentally alter their subsistence strategy, adopting the broader, more flexible approach of Homo sapiens, or geographic separation would have had to reduce direct competition, allowing both populations to persist in different regions. None of these scenarios occurred in the actual past. The climate remained unstable. Neanderthals maintained their specialized strategies. The populations overlapped and competed, and eventually demographic pressures led to extinction. Understanding these pressures, these ecological mechanisms, is essential for imagining what survival would have required and what a persistent Neanderthal population would look like in the millennia that followed. Population size matters in ways that aren't always immediately obvious. A large population can absorb shocks that would devastate a small one. Lose 100 individuals from a population of 10,000, and the group recovers easily. Lose 100 from a population of 500, and you've triggered a crisis. Neanderthals appear to have lived in small populations throughout their history. Genetic analysis of the limited ancient DNA available suggests low genetic diversity, consistent with small effective population sizes maintained over long periods. Archaeological evidence supports this picture. Neanderthal sites are sparse compared to the density of Homo sapiens occupation in the same regions during later periods. The traces they left on the landscape are light, suggesting low population densities. This wasn't necessarily a weakness under stable conditions. Small populations living in tight-knit groups can be highly successful. They can maintain social cohesion, share knowledge effectively within the group, and exploit local resources efficiently. The Neanderthal pattern of small, dispersed populations worked for hundreds of thousands of years. But small populations are vulnerable in specific ways. One is genetic. With fewer individuals, there's less genetic variation to draw on when conditions change. Beneficial mutations are less likely to appear. Harmful mutations are more likely to become fixed through random drift. Inbreeding becomes more likely. particularly if groups become isolated from each other, leading to reduced fitness and increased susceptibility to disease. Another vulnerability is demographic. Small populations have narrower margins for error. A single catastrophic event, a harsh winter, an epidemic, a localized environmental disaster, can eliminate a significant fraction of the population. Recovery depends on the survivors being able to reproduce quickly enough to rebuild numbers before the next crisis hits. Neanderthal populations faced repeated crises. The climate instability of the late Pleistocene, discussed in the previous chapter, created recurring periods of resource scarcity. Each downturn would reduce population numbers. During favourable periods, populations would recover. But if the recovery is incomplete before the next downturn arrives, the baseline population trends gradually downward. This creates what ecologists call a demographic trap. The population oscillates, but with a downward bias. Each low point is slightly lower than the previous one. Each recovery is slightly less complete. The trend is toward extinction, not through a single catastrophic event, but through gradual erosion. The small group size characteristic of Neanderthal social organization exacerbated this vulnerability. As discussed earlier, their brain structure appears to have supported smaller social networks compared to Homo sapiens. This meant their communities were more isolated from each other, with less frequent exchange of individuals between groups. When a local population suffers losses, recovery depends on reproduction within the group or immigration from outside. For Neanderthals, immigration was apparently limited. Groups were separated by distance, by territory, by social boundaries. A population crash in one region couldn't easily be offset by individuals moving in from elsewhere. This also affected cultural resilience. In a large, interconnected population, knowledge can be distributed. If one group loses critical information, perhaps through the death of key individuals, they can reacquire it from neighboring groups. In small, isolated populations, knowledge loss can be permanent. A technique for processing a particular resource, a strategy for dealing with a specific challenge. If the individuals who hold that knowledge die without transmitting it, the entire group loses access. Archaeological evidence suggests this may have happened. Some Neanderthal sites show evidence of sophisticated behaviors that appear in one period and then disappear. Ornamental objects appear at some sites, but not others. Certain tool types show up and then vanish from the record. This pattern is consistent with small, partially isolated populations occasionally innovating or adopting practices from neighbours, but then losing those practices when circumstances change. Homo sapiens populations, with their larger group sizes and more extensive networks, were more resilient. A crisis affecting one group could be buffered by connections to other groups. Knowledge was more widely distributed, less likely to be lost. Population losses in one area could be replenished through migration from neighbouring regions. The demographic difference also affected competitive dynamics. When two populations exploit the same resources, the one with larger numbers and faster population growth has an advantage. They can occupy more territory, exploit resources more intensively, and recover from setbacks more quickly. Over time, this advantage compounds. Homo sapiens populations expanded, while Neanderthal populations contracted. The territories available to Neanderthals shrank as Homo sapiens groups moved in. The resource base available to each Neanderthal group diminished as they were increasingly confined to smaller ranges. There's also the issue of territoriality and competition between groups. In small populations living in small groups, each community needs a substantial territory to support itself, particularly if they're relying on large game hunting. As Homo sapiens populations expanded, they would increasingly encroach on these territories. Neanderthals might retreat, avoiding direct conflict, but retreat means giving up resources, accepting a smaller range, living under more constrained conditions. The combination of small population size, limited connectivity between groups, high resource requirements, and increasing competition created a situation where Neanderthal populations were being squeezed from multiple directions. Environmental pressures reduced their primary food sources. Competition reduced their territory. Their social structure limited their ability to adapt quickly or recover from losses. Genetic modelling of this process shows how quickly it can lead to extinction once the downward trend begins. A population declining even slightly per generation reaches critical thresholds relatively rapidly. Once numbers drop below a certain point, inbreeding effects intensify, genetic diversity collapses further, and recovery becomes statistically unlikely even if conditions improve. The final Neanderthal populations appear to have persisted in refugia, small pockets of favourable habitat in southern Europe and Western Asia. These were the last holdouts, groups clinging to existence in marginal territories, while Homo sapiens dominated the more favourable regions. The archaeological record shows their numbers dwindling, sites becoming sparser, until finally the record goes silent. For Neanderthals to have survived this demographic trap, several things would need to be different. They would need either larger initial population sizes, which would require either higher population densities or broader geographic range, or they would need stronger connectivity between groups, allowing gene flow and knowledge exchange that could buffer local population crashes, or they would need to reduce their per capita resource requirements, making their populations more sustainable on available resources. Each of these changes would represent a significant shift from the pattern established over hundreds of thousands of years. Not impossible, populations can change when selective pressure is strong enough, but difficult, requiring transformation of both biological traits and social organization within the compressed timeframe of a few thousand years. In the actual past, none of these changes occurred sufficiently. The demographic trap closed, the last populations disappeared. But in contemplating survival, we have to imagine a scenario where some combination of these factors shifted enough to allow persistence. Perhaps a geographic barrier separated Neanderthal and Homo sapiens populations sufficiently to reduce competition. Perhaps climate stabilization occurred earlier, allowing populations to recover before the next crisis. Perhaps social structure shifted toward larger, more connected groups. Any of these would have allowed survival, but they would also have resulted in a population that looked somewhat different from the Neanderthals who actually lived during the late Pleistocene. The surviving lineage would be one that had adapted, that had found ways to mitigate the vulnerabilities that led to extinction in the historical timeline, and those adaptations would shape everything about how they lived in the millennia that followed. To imagine Neanderthal survival, we need to identify what would have had to change, not what could have changed through magic or authorial convenience, but what might plausibly have been different given what we know about their biology, their culture, and the environmental conditions they faced. The most straightforward path to survival would have been geographic separation. If Neanderthal and Homo sapiens populations had occupied different regions, with limited overlap, the competitive pressure would have been reduced. Both species could have persisted in their respective territories, adapting to local conditions without directly competing for the same resources. This isn't entirely hypothetical. For much of their history, the two species were geographically separated. Neanderthals evolved and lived in Eurasia while Homo sapiens remained in Africa. The extinction only occurred after Homo sapiens migrated out of Africa and into Neanderthal territory. If that migration had been delayed, or if it had taken a different route that bypassed major Neanderthal populations, both species might have continued along their separate trajectories. Geographic barriers could have maintained this separation even after initial contact. Mountain ranges, ice sheets, bodies of water, these features limit movement and gene flow. If Neanderthals had been concentrated in regions that Homo sapiens found less attractive or accessible, both populations could have persisted without intensive interaction. But pure geographic separation seems unlikely to have been maintained indefinitely. Both species were mobile, capable of moving across varied terrain, adapting to different environments. Eventually, populations would have expanded into overlapping territories. Geographic separation might delay competition, but probably not prevent it entirely. A more stable solution would involve ecological separation. If the two species specialized in different resources or occupied different ecological niches, they could coexist in the same regions without direct competition. This pattern, called niche partitioning, is common in ecology. Multiple similar species coexist by focusing on different food sources, different habitats, or different times of activity. For this to work with Neanderthals and Homo sapiens, their subsistence strategies would need to diverge more sharply than they did historically. Perhaps Neanderthals could have specialized even more intensively in high-latitude, cold-adapted hunting, occupying tundra and northern forest environments that Homo sapiens found less suitable. Meanwhile, Homo sapiens could have focused on temperate and Mediterranean zones, exploiting the more diverse resources available in those regions. Or perhaps Neanderthals could have developed stronger aquatic resource exploitation. Their robust build would have given them advantages in cold water diving, in hauling nets, in processing large marine mammals. Coastal and riverine resources are highly productive and could have supported substantial populations without competing directly with terrestrial hunting strategies. But ecological specialization of this sort typically requires long periods to develop. It's not something that happens in a few generations. It requires both biological adaptation and cultural innovation, the development of specialized technologies and knowledge systems. For Neanderthals to have shifted toward a distinct ecological niche during the critical period of overlap with Homo sapiens would have required rapid, directed change under intense selective pressure. Another possibility involves cultural adaptation. Specifically, Neanderthals could have adopted key aspects of Homo sapiens' social organization and subsistence strategies. We know from archaeological evidence that some cultural exchange occurred. Neanderthals in their final millennia showed evidence of adopting Upper Paleolithic technologies and practices. If this adoption had been more extensive and occurred earlier, it might have leveled the competitive playing field. Imagine Neanderthals shifting toward larger group sizes, developing more extensive trade networks, adopting broader subsistence strategies that included more fishing, plant processing, and small game hunting. These changes wouldn't require biological evolution. They're cultural practices, transmissible through learning and imitation. The challenge is that culture doesn't exist independently of biology. The social structure of Neanderthals, their tendency towards smaller groups, appears to have been at least partially constrained by brain organization. Their dietary preferences, their focus on large game, was supported by their physiology and their skill set. Changing these patterns would require working against established biological predispositions. Not impossible. Culture can override biology. Humans regularly engage in behaviors that contradict our evolved preferences when cultural norms or practical necessity demands it. But it's difficult, particularly for changes that need to spread rapidly across entire populations. For Neanderthals to have successfully adopted Homo sapiens-style social organization, there would need to have been strong incentives, clear benefits that made the costs of change worthwhile. And there would need to have been enough time for these changes to spread and become established before competitive pressure became overwhelming. A hybrid scenario seems most plausible. Some degree of geographic or ecological separation, reducing direct competition enough to buy time, combined with some degree of cultural adaptation, allowing Neanderthal populations to become more resilient and competitive. The surviving populations might have been those in refugia that happened to have particularly favorable conditions, or those that had the good fortune to adopt beneficial innovations early, or those that were geographically isolated enough to avoid the worst of the competitive pressure. These populations wouldn't have been identical to the Neanderthals who lived during the period of overlap. They would have been shaped by survival itself, selected for traits and behaviors that allowed persistence. Perhaps they would have been the populations with slightly larger group sizes, or those who had already begun diversifying their diet before contact, or those who lived in regions with particularly stable resources. The point is that survival would have required something to be different. The historical trajectory led to extinction. For the path to diverge, conditions, behavior, or both would need to change, and those changes would shape the character of the surviving population. If we imagine Neanderthals persisting past the bottleneck of the late Pleistocene, surviving into the Holocene and beyond, we're imagining a lineage that successfully navigated these challenges. They would carry the marks of that survival, the adaptations and compromises that allowed them to persist when other populations didn't. Those adaptations would continue to shape their path through subsequent history. The Neanderthals who survived wouldn't simply resume their old patterns once the crisis passed. They would be changed by the experience, their culture, and possibly their biology, bearing the imprint of the selective pressures they endured. Understanding this is crucial for imagining what a surviving Neanderthal population would look like in later periods. They wouldn't be living fossils, unchanged from their Pleistocene ancestors. They would be a population shaped by their unique history, by the specific path that led to their survival, carrying forward both their deep evolutionary heritage and the more recent adaptations that allowed them to persist. The development of agriculture, beginning roughly 12,000 years ago in several independent centres around the world, represents one of the most significant transitions in human history. It transformed subsistence, settlement patterns, population sizes, social organisation, and ultimately made possible the complex civilizations that followed. For Homo sapiens populations, this transition occurred through a gradual process. Wild plants were selectively harvested, then intentionally planted, then deliberately bred for favourable traits. Wild animals were managed, then confined, then selectively bred. Over generations, this produced domesticated crops and livestock fundamentally different from their wild ancestors, optimized for human use. The transition wasn't universally adopted simultaneously. Some populations embraced agriculture early and intensively. Others maintained hunting and gathering lifestyles for millennia after agriculture was available. The choice depended on local conditions, available resources, cultural factors, and the relative benefits of each strategy. If Neanderthals had survived into the Holocene, they would have faced the same conditions that prompted Homo sapiens to develop agriculture. Climate stabilization after the end of the Pleistocene, the extinction or reduction of megafauna populations, increasing human population densities, making traditional hunting and gathering less sustainable. These pressures would have affected both species. The question is how Neanderthals would have responded. Their robust physiology and high caloric requirements are relevant here. Agriculture, particularly in its early phases, is labour-intensive and often provides lower returns per unit of effort compared to successful hunting. Early crops, before thousands of years of selective breeding, were smaller and less productive than modern varieties. The caloric return on agricultural labour was initially modest. For a population with lower caloric needs, this trade-off might be acceptable. The reliability of agricultural resources, the ability to store surplus, the support for larger populations, these advantages could outweigh the lower efficiency. But for Neanderthals, with their higher energy requirements, the calculation would be different. A diet based primarily on cultivated grains and legumes, the foundation of most early agricultural systems would require consuming large quantities to meet their caloric needs. Early agriculture also involved significant manual labour. Clearing land, tilling soil, planting, weeding, harvesting, processing, all of this demanded time and energy. The Neanderthal physique, built for power rather than endurance, might have been poorly suited to the sustained, repetitive labour of farming. This suggests that Neanderthals might have been culturally resistant to adopting agriculture, at least in its grain-based form. They would have had practical reasons to prefer continuing their traditional hunting-based subsistence, supplemented by gathering and perhaps some management of wild resources. However, we shouldn't assume they were incapable of agricultural innovation. The cognitive capacity was present. Neanderthals were intelligent, capable of long-term planning, skilled at manipulating their environment. If agriculture offered sufficient advantages, they could have developed it independently or adopted it from Homo sapiens neighbours. The form their agriculture took might have been different. Rather than focusing on grain cultivation, Neanderthals might have emphasized animal husbandry. Raising livestock, particularly large herbivores, that could provide substantial meat and fat would align better with their physiological needs and existing skill sets. Imagine Neanderthal populations developing intensive pastoral systems. Rather than cultivating fields of wheat or barley, they manage herds of cattle, horses, or reindeer. The labour required is different from crop agriculture, involving animal management, moving herds seasonally, defending against predators. This kind of work might suit their physical capabilities better than tillage farming. Pastoral societies in human history have tended toward different social organisations than agricultural ones. They're often more mobile, following herds through seasonal ranges. They maintain smaller settlement sizes, with more dispersed populations. Social structure tends to emphasise kinship and clan relationships, rather than the more complex hierarchies that develop in settled agricultural states. This pattern would align with Neanderthal tendencies towards smaller social groups. A pastoral economy wouldn't require them to adopt the large, densely populated settlements that characterized agricultural civilizations. They could maintain their preference for more intimate communities while still shifting away from pure hunting and gathering. Geographic distribution would also be affected. Pastoral societies typically occupy marginal lands, regions where crop agriculture is difficult, but grasslands or tundra can support herbivore populations. These are often higher latitude or higher elevation zones, the kinds of environments where Neanderthals were already well adapted. This creates a plausible scenario where both species develop food production systems but in different forms. Homo sapiens focuses on intensive agriculture, developing grain-based systems that support large, dense populations in favorable climatic zones. Neanderthals develop pastoral systems, maintaining smaller populations in the colder, more marginal regions where their cold adaptations remain advantageous. Such specialization would reduce direct competition. The two species would occupy different ecological and economic niches, interacting through trade and occasional conflict at boundaries, but not competing intensively for the same resources in the same territories. However, there's a demographic consequence to this division. Agricultural societies, once established, support much larger populations than pastoral ones. The ability to produce dense calories from cultivated land allows population growth that pastoralism can't match. Over the long term, this means Homo sapiens populations would vastly outnumber Neanderthals. This demographic imbalance would shape all subsequent interactions. In any conflict or competition, numbers matter. The larger population has advantages in warfare, in economic production, in cultural influence. Neanderthals, even if successfully maintaining their own societies, would be perpetually the demographic minority. Their robust physiology, which initially made intensive agriculture less attractive, would become an economic specialization. In a world where both species coexist, each would recognize the other's physical capabilities. Neanderthal strength and cold tolerance would be valuable for specific economic roles. In pre-industrial societies, certain tasks require immense physical power. Moving large stones, operating heavy equipment, working in mines, processing tough materials. Neanderthals would naturally excel at these activities. Their robust build, which was a liability in terms of caloric efficiency, becomes an asset in specific labor contexts. Over time, this could lead to economic specialization by species. Certain occupations become predominantly Neanderthal domains because they align with physiological advantages. This isn't slavery or coercion, at least not necessarily. It's comparative advantage, the economic principle that individuals and populations specialize in activities where they're relatively more efficient. But specialization by species creates social stratification by species. If Neanderthals are disproportionately represented in physically demanding low-status labor, while Homo sapiens dominates agriculture, trade, and eventually urban occupations, this creates systemic inequality. The transition to agriculture, therefore, would be a pivotal moment for a surviving Neanderthal population. How they adapted to the Holocene, whether they developed their own form of food production or were integrated into Homo sapiens agricultural systems, whether they maintained geographic separation or increasingly coexisted in mixed economies, these choices would set trajectories that would shape the species' relationship for all subsequent history. The robust body that was an adaptation to Ice Age hunting would become, in the agricultural and eventually industrial age, a defining economic characteristic. Not a relic of the past, but an ongoing biological reality with concrete implications for how Neanderthals fit into human economic and social systems. By the modern industrial era, if Neanderthals had survived, their defining characteristic would be unmistakable. Not their facial structure, not their larger eyes, but their physical power. The robust build that evolved for Ice Age hunting would persist, a permanent biological inheritance distinguishing them from Homo sapiens. This isn't speculation. Absent selective pressure to change, morphological traits persist. The Neanderthal body, with its heavy bones, broad chest, powerful musculature, would remain fundamentally unchanged. Tens of thousands of years is insufficient time for dramatic morphological evolution without strong directional selection. And in most environments humans occupy, there would be no particular advantage to losing that robusticity. In a pre-industrial world, strength is directly valuable. Physical labor is the primary source of mechanical energy. Moving goods, constructing buildings, working in mines and quarries, processing raw materials, all of this depends on human and animal muscle. The stronger the individual, the more work they can accomplish. Neanderthals would have substantial advantages in these domains. Their skeletal structure, their muscle attachment sites, their overall build, all of this translates to greater force production. They could lift heavier loads, work longer without fatigue in tasks requiring strength rather than endurance, perform dangerous physical tasks with greater safety margins. This advantage would be recognized and economically exploited. In any society where both species coexist, employers seeking workers for physically demanding tasks would prefer Neanderthals. Not out of prejudice or discrimination, but out of simple efficiency. A Neanderthal worker might accomplish in one day what requires 2 or 3 Homo sapiens workers. Over time, this creates occupational sorting by species. Certain industries become predominantly Neanderthal. Deep mining operations, where ore must be extracted from hard rock faces and hauled through confined spaces. Quarrying, where massive stones must be split and moved. Heavy construction, where beams and blocks must be positioned with minimal mechanical assistance. Foundry work, where strength and heat tolerance are both required. The pattern extends into the industrial age. Even with mechanization, many industrial processes require significant physical input. Operating heavy machinery, maintaining industrial equipment, working in environments that are hot, cold, or physically demanding. Neanderthals would continue to dominate these sectors. Consider maritime industries. Commercial fishing, particularly in cold waters, requires strength, cold tolerance, and the ability to work on unstable platforms in harsh conditions. Neanderthals would be naturally suited to this work. Offshore resource extraction, oil platforms in the North Sea or Arctic waters would be another domain where their adaptations provide clear advantages. Construction remains relevant even in highly developed economies. Someone must operate equipment, position materials, perform the physical tasks that machines can't fully replace. Neanderthals would be overrepresented in construction trades, particularly those involving heavy materials or challenging conditions. Emergency services present another specialization opportunity. Firefighting requires entering dangerous environments, working in extreme heat, performing physically demanding rescues. Search and rescue in wilderness or disaster settings requires strength and endurance. These roles would attract Neanderthal workers, and Neanderthal communities might develop cultural traditions around these occupations. The pattern creates a form of economic stratification that maps onto species. Not absolute, individuals of both species work in all fields, but statistical. Certain occupations have workforce demographics that skew heavily toward one species or the other. This has social implications. Occupational identity is powerful. The work you do shapes how you see yourself and how others see you. If Neanderthals are concentrated in physical labor, this becomes part of their collective identity. They might take pride in their strength, build cultural values around physical capability, emphasize toughness and endurance as virtues. But occupational concentration can also create vulnerabilities. Physical labor, particularly in industrial settings, is often lower status than white-collar work. It's frequently more dangerous, with higher rates of injury and chronic health problems. It tends to pay less well, particularly as automation reduces demand for manual labor. If Neanderthals are overrepresented in these sectors, they face systematic disadvantages in income, health outcomes, and social mobility. This isn't because of any cognitive limitation. As we've established, Neanderthals were fully intelligent. But if economic opportunity is structured such that the jobs most available to them are also the most dangerous and lowest paid, systemic inequality results. Educational systems might reinforce this pattern. If Neanderthal children see adults in their communities working primarily in physical trades, they might be tracked toward vocational training rather than academic preparation. Not through any explicit policy, but through subtle channeling, lower expectations, practical considerations about what careers seem accessible. Over generations, this creates a self-reinforcing cycle. Economic specialization leads to cultural identity built around that specialization, which influences educational and career choices, which maintains the specialization. Breaking out of this pattern requires conscious effort, institutional change, active work to create opportunities in fields where Neanderthals are underrepresented. There would also be geographic concentration, industries cluster, mining regions, industrial centers, ports. These areas would attract Neanderthal populations. Over time, this creates demographic patterns where certain regions have high Neanderthal populations while others have very few. This geographic sorting affects political representation. If Neanderthals are concentrated in specific regions, their political influence is likewise concentrated. They might have strong representation in regional governments, where they're demographically significant, but minimal voice in national politics, where they're a dispersed minority. The economic value of Neanderthal strength also creates potential for exploitation. History is full of examples where economically valuable populations are subjected to coercive labor systems. If Neanderthal physical capability is highly valued, there would be temptation to exploit it through unfair labor practices, debt bondage, or outright slavery. Legal protections would be essential to prevent this. Labor laws, anti-discrimination statutes, regulations on working conditions, all of these would need to be structured to protect Neanderthal workers from exploitation. The challenge is that enforcement requires political will, and if Neanderthals are a demographic minority, they might lack sufficient political power to ensure strong protections. The modern economy also presents challenges. Automation increasingly replaces physical labor. Jobs that once required human strength can be performed by machines. This technological change would disproportionately affect Neanderthal employment. The economic niches where they had natural advantages would contract, requiring adaptation into fields where their advantages are less clear. This isn't an insurmountable challenge. Populations adapt to changing economic conditions constantly. But it requires investment in education, training, and support for workers transitioning between sectors. If that support is inadequate, technological unemployment would hit Neanderthal communities particularly hard. The fundamental issue is that a biological characteristic, the robust physique that evolved for completely different reasons hundreds of thousands of years ago, becomes economically and socially significant in the modern world. Strength, which was simply an adaptation to Ice Age conditions, becomes a defining feature shaping employment, income, social status, and political power. This is the reality of living in a body that differs significantly from the demographic majority. The differences matter, not because they reflect inherent superiority or inferiority, but because they interact with social and economic structures in ways that create systematic patterns. Understanding these patterns is essential for imagining how a two-species world would actually function, beyond abstract theorizing, in the concrete reality of who works where and why. Language is often described as the defining feature of human cognition. It's the medium through which we think complex thoughts, transmit culture across generations, coordinate large-scale social activities. Any species that possesses language possesses something fundamental to humanity. Neanderthals had language. The evidence for this is strong, though not as direct as we might wish. Their hyoid bone, a small bone in the throat that anchors muscles involved in speech, is anatomically similar to that of modern humans. Their inner ear structure, which affects both hearing and the production of speech sounds, falls within the human range. They possess the FOXP2 gene variant associated with speech and language capacity in Homo sapiens. More compellingly, their archaeological record shows behaviors that are difficult to explain without language. Coordinated hunting of large, dangerous animals requires planning and communication. The transmission of complex technical skills like the Levallois stoneworking technique is more efficient with linguistic instruction than with pure observation. Their symbolic behaviors, cave art, and burial practices strongly suggest the capacity to think and communicate about abstractions. So, Neanderthals spoke. They had languages, possibly many languages given their geographic spread and temporal depth. But here's the question that matters for our hypothetical scenario. Would Neanderthal languages have been structured the same way as Homo sapiens languages? Or would the differences in brain organization have created linguistic differences? Human language, as studied in Homo sapiens populations, shows certain universal features. All languages have systems of distinct sounds that combine to form meaningful units. All have grammar, rules for how words combine into phrases and sentences. All show recursion, the ability to embed structures within structures, allowing infinite expression from finite elements. These universals are thought to reflect the underlying architecture of the human language faculty, the cognitive systems that make language possible. But those cognitive systems reside in specific brain structures, and, as we've discussed, Neanderthal brain organization differed from that of Homo sapiens, particularly in regions associated with higher-order processing and social cognition. The areas of the brain most involved in language include Broca's area and Wernicke's area, regions in the frontal and temporal lobes responsible for language production and comprehension. These areas exist in both Neanderthals and Homo sapiens. But language also depends on connectivity between brain regions, on working memory capacity, on the ability to process nested hierarchical structures. These capacities are supported by the parietal lobes and portions of the cerebellum, precisely the regions that were proportionally smaller in Neanderthals. This suggests that while Neanderthals had language, the processing limits might have been different. One possibility is that Neanderthal languages were less recursive than Homo sapiens languages. Recursion, the embedding of phrases within phrases to create complex hierarchical structures, is computationally demanding. It requires holding multiple levels of structure in working memory simultaneously. If Neanderthal working memory was more limited, their languages might have used recursion less extensively, favoring simpler syntactic structures. This doesn't mean their languages would have been primitive or impoverished. Languages with limited recursion can still express complex thoughts, just through different structural strategies. They might use more concatenation, stringing clauses together sequentially rather than embedding them. They might rely more heavily on context, leaving implicit what Homo sapiens languages make explicit through complex grammar. Another possibility involves the relationship between language and spatial cognition. Neanderthal brains, with their enhanced visual processing and spatial reasoning capabilities, might have produced languages that were especially rich in spatial and locational information. Precise descriptions of landscapes, of the relationships between objects in space, of movement and position, these might have been particularly elaborated. Meanwhile, aspects of language that depend on large-scale social cognition might have been less developed. Homo sapiens languages have complex systems for encoding social relationships, for marking status and hierarchy, for distinguishing subtle degrees of formality and intimacy. These features serve the needs of large, complex social networks. Neanderthals, with their smaller group sizes and more intimate social structures, might have had simpler social marking in their languages. The practical implication is that a surviving Neanderthal population would speak languages that were recognizably language, fully expressive and capable of complex communication, but structurally distinct from Homo sapiens languages in subtle but consistent ways. Translation between the two language types would be possible but imperfect. A Homo sapiens linguist could learn a Neanderthal language and become fluent. A Neanderthal could likewise learn a Homo sapiens language. But there would be aspects of each system that didn't map cleanly onto the other. Certain concepts that Homo sapiens languages express easily through complex embedded clauses might require circumlocution in Neanderthal languages. Conversely, the precise spatial and environmental descriptions natural to Neanderthal languages might be awkward to reproduce in Homo sapiens languages without extensive elaboration. This creates practical challenges in a mixed society. Legal language, with its complex hierarchical structures and embedded qualifications, might be particularly difficult to translate into Neanderthal languages. Scientific and technical discourse, which often relies on abstract recursion, might likewise pose challenges. Educational systems would need to account for this. Neanderthal children learning in Homo sapiens-dominated schools might struggle not because of cognitive limitations, but because the language of instruction is structurally optimized for a different cognitive profile. Teaching would need to be adapted, concepts presented in ways that align with how Neanderthal languages naturally structure information. There's also the question of language prestige. In any bilingual or multilingual society, some languages have higher status than others. If Homo sapiens languages dominate government, commerce, science, and high culture, they become prestige languages. Neanderthal languages might be relegated to domestic and community use, seen as less sophisticated or less suitable for serious discourse. This would be unjust. Linguistic differences don't reflect inherent value. But prestige hierarchies aren't about justice. They're about power and demographic dominance. If Homo sapiens are the majority population, their linguistic norms become the standard against which other languages are judged. Neanderthal communities would need to actively maintain their languages in the face of this pressure. Language preservation requires institutional support, education in the heritage language, use in formal contexts, resistance to the assumption that the majority language is superior or more useful. The existence of two human language types also raises fascinating theoretical questions for linguistics. The study of language universals assumes a single human language faculty. With two species producing language from differently organized brains, researchers could investigate which features are truly universal, present in all human language regardless of cognitive architecture, and which are specific to Homo sapiens' brain organization. This comparative approach would revolutionize the field. Questions about the relationship between language and thought, about how grammar reflects cognitive processing, about the limits and possibilities of linguistic structure, all of these could be addressed through direct comparison rather than theoretical speculation. But for the individuals actually living in this linguistic landscape, the theoretical interest would matter less than the practical reality. They would navigate a world where communication across species lines is possible but requires effort, where misunderstandings arise from structural incompatibility rather than lack of goodwill, where language itself is a marker of species identity and a potential site of inequality. The structure of thought, encoded in the structure of language, would be visibly different between the two populations, and that difference would be a daily, lived reality, shaping education, law, literature, interpersonal relations, and the subtle but pervasive experience of being understood, or not quite understood, across the human species divide.